Let's look at this application problem. Here we have a rectangular box resting on the xy plane with one vertex at the origin. The opposite lies in the plane, described by this equation. Find the maximum volume of such a box. Before we do anything, we have to really think, what do we have? So I have a three-dimensional chart and I have a rectangular box like that, okay? And according to the problem, it's resting on the xy plane, okay, not like floating around in space. Moreover, I have one vertex at the origin, and it's opposite, so that would be this vertex lying in a plane, right? So my box here is not exactly right because I don't have a vertex at the origin. So what I have is one point here, and this should be the z-axis, and another point lies on the plane described by 6x plus 4y minus plus 3z equals 24. So the opposite vertex is sitting on the plane. So let me then sketch this out. So I have a box like this, all right? And I want to find the maximum volume of such a box, okay? So now I can say, oh, if I call x, y, z, okay, so x would be this length, y would be this length, and z would be from the xy plane to this point on the plane here. So z would be the height. So I can say let variables x, y, z represent the length, width, and the height of the box. If so, then what do I have? I would have, first of all, z can be expressed in terms of x and y, okay? Because z needs to be the z coordinate of the point on the plane. So that will be 24 minus 6 minus 4y, then divided by 3, right? 2. The volume is length times width times height, but because z can be expressed in terms of x and y, we have volume can be expressed as x and y. So that will be x times y times 1/3 of 24 minus 6x minus 4y. Okay, so that would be my function of x and y. Now goal is to find maximum of v, which v, this v, right? So what do? We use the second partial derivative test to find the max, right? So then we'll need to do what? We'll need to do 1, find critical points of V. 2, find the determinant of the Hessian for the V, and we also need the value for or the sign. We need to know whether it's a positive or negative for the VXX. Okay, then 3, apply the second partial derivative test to help us find the max volume. All right, so apparently you can see I'm running out of space, so what I'm gonna do is to erase the caution and then go from the top. Okay, then I'll also erase this later, but I'm gonna try to keep it as long as possible. So, and that's find critical point. First of all, I'm gonna need to find Vx. So let me actually simplify this a little bit, because this looks a little bit ugly. So x times y times 1/3 times 24, that is 8xy. Then the next term is minus 2x squared y, because of x, x, and 1y, minus 4/3 xy squared. Okay, so this is my function v of xy. Differentiating this with respect to x, I get 8y minus 4xy minus 4/3 y squared. Okay, double check. Differentiating with respect to x, so this becomes 1, this becomes 2x, and this becomes 1. Okay, so it looks okay. Set this equals 0. Find dv dy, treating x as a constant. So I get 8x. Here I get minus 2x squared. And here I get minus 8/3. What do I have there? xy. And set this derivative equal to 0 as well. Okay. Then solve for x and y, because I'm looking for what? Critical points. Okay. So this gives me the first equation. Every term has a y. I can factor out y, and I can factor out 4 as well. So 4y times 2 minus x minus 1/3 y equal to 0. Here I can factor out a 2 because all the numbers contains an even number there, and they all contain an x. I can factor out an x as well. So I'm left with 4 minus x minus 4/3 y. Okay. So now I can see that to solve x and y, to solve this equation, it's either x equals 0 or this whole thing equals 0. To solve this equation, it's either x equals 0 or this whole thing equals 0. So let me write it down. So it's either this or 2 minus x minus 1/3 y equals 0. Right? x equals 0 over 4 minus x minus 4/3 y equals 0. Okay, so now notice that x, y, z, they have physical meanings. They represent the length of the sides of the box. So if any of this is equal to 0, if x is equal to 0, then you don't have volume, just like a piece of paper, like this, right? So I know that if x equals 0, this will not give me maximum volume because I don't have a volume. If y equals 0, I again don't have maximum volume because I don't even have a volume. And that comes from the assumption that I said x, y, z represent the length, width, and height of the box. Okay? So now I only want to focus on this situation. Okay? So the only meaningful critical point will come from the solution of these equations. Okay? I don't want x equal to 0. I don't want y equal to 0. Okay? Because either case does not give me volume of a box. I don't even have a box. Alright? So I'll solve that. I have what? So I can number this equation 1. I can call this equation 1. I can call this equation 2. Okay. Use whatever way you can to solve for x and y. I'm gonna do equation 2 minus equation 1. So 4 minus 2, that is a 2. Minus x minus a negative x, that's a 0. Okay? Let me write down for you. So 4 minus 2 minus x minus negative x minus 1/3 y minus 1/3 y equal to 0. Okay? So I do equation 2 minus equation 1. So here I have 2, this goes away because they cancel, minus y sorry, I have a mistake here. Let me do this again. So I have 4 minus x minus 4/3 y equals 0. Now minus 2 minus x minus 1/3 y with parentheses minus 0. Okay? So here I have 4 minus 2, that's a 2. I have negative x plus x, so plus 0. I have minus 4/3 y plus 1/3 y, so that is minus y and equals 0. Okay? So this gives me y is equal to 2. And when y equals 2, plug y equal to 2 into either of these equations. So let me just do 1. I have 2 minus x minus 1/3 times 2. So let me just write it as 2/3 equals 0. So this tells me x is equal to 4/3. Okay? Just use whatever way you prefer to solve these equations here. Okay? So now I have a critical point 4/3 2 for the volume function. Now I'm gonna use the second partial derivative test to argue this does give me a maximum volume. So to move forward, I will need to find the second derivatives of v. Okay, I have first derivatives written down here. I'm gonna keep it here, but I will erase everything else. Okay, pause the video if you need to, and I'm gonna erase this. So next, I need to find second order derivatives and see what happens. All right, so take this one, dv dx, differentiating with respect to x, 0 minus 4y minus 0, so I get minus 4y. dv dxy. So again, take this differentiating with respect to y, 8 minus 4x minus 8/3 y. Okay. vyy. Take this differentiating with respect to y, so I get 0 minus 0 minus 8/3 x. Okay. So I only care about what happens at the critical point. So I'm gonna just evaluate these functions at the critical point. Okay. I have minus 8 here. I have 8 minus 16/3 minus 16/3. So this gives me, what is that? 24 minus 16 minus 16/3. So this is minus 8/3. Okay. vyy, here I have minus 8/3 times 4/3. So this is a negative 32/9. All right, so pay attention that this guy is negative. Not done yet. Find the d. So d is minus 8 minus 8/3 minus 8/3 minus 32/9. Okay, take the determinant. So I have 256/9 minus the multiplication of these two numbers. So that's 64/9. All right, so apparently this will be a positive number. I don't really care about the value. I just want to know whether it's a positive or negative. So d positive together with vxx negative, what do I have? Second partial derivative tells you V at the critical point. Okay, you can evaluate this. So that would be I don't remember, xy times what is the V function? V is xy times 1/3 times 24 minus 6x minus 4y. I think it's this one. Okay, so I have 8xy minus 2x squared y minus 4/3 xy squared. Let me get it. Yeah. So this is 8 times 4/3 times 2 minus 2 times 4/3 squared times 2 minus 4/3 times 4/3 times 2 squared. Okay. So I don't need this function here. Let me just compute this on the side. So this is 16 times 4. 16 times 4 minus, this is 16 times 4 over 9 minus this. Okay. All right. So make a common denominator. I would have one copy of, I feel I did something wrong, so times 4. Okay, so 16 times 4 is not equal to 56. It's equal to 64. All right. So I have 3 copies of 64 minus a copy of 64 and minus another copy of 64. So this gives me 64 over 9 is the maximum volume. All right. Cubic unit. Okay. So it sounds a little complicated, but if you really think about it, it's just find the local extrema.